Welcome to Math with Professor V. Here's your latest integral of the day. We have an indefinite integral of x times cosine cubed of x squared times the square root of sine of x squared dx. And I had some requests lately to do some less spicy integrals, so hopefully this one's still fun, yet not excessively challenging, so that you guys can all arrive at the solution on your own. So if you want to pause the video, give it a try. It just takes a couple of rounds of substitution. All right, well, jumping right in, I'm not loving the fact that we have cosine and sine of x squared, but then I take a peek over here and here's this lonely little x. So I'm thinking, ooh, it's definitely time to do a u sub just to simplify the integrand a wee bit. So let's go ahead, let's let u equal x squared. Then du is 2x dx. All I have is x dx, that's fine. So then 1/2 du is x dx. So I'm going to go back now, rewrite this integral all in terms of u. I'm going to put this 1/2 outside, and then I have cosine cubed, just u now, square root of sine of u, very good, and then du. Beautiful. Okay, how to proceed from here? We can play around with this cosine cubed u quite a bit, right? I can break it up, but this sine u underneath the radical, we are stuck with it. And this is not going to be easy to deal with. So I'm thinking most likely I'm going to make another substitution. And in that substitution, I want to let t, because I already used up u, t be sine of u. Let's see what I would need in order to make this substitution a success. This is where I'm thinking. So dt would be cosine u du. Do I have that somewhere? I certainly do. In fact, I have 3 cosines. I only need 1 to get absorbed when I substitute in dt. I'm still going to have 2 more left. Is that problematic? No, because if I have cosine squared u, I can use my Pythagorean identity and rewrite it in terms of sine. So things are going to just fall into place nicely. So before I make my substitution, let me go ahead, rewrite the integrand so we're ready to roll. So this cosine cubed u, remember that's cosine squared u times cosine u. And the cosine squared u I'm going to rewrite as 1 minus sine squared u. Then I have rad sine u, and then don't worry, that 1 extra cosine u, I'm going to put it at the end with du. So everybody's paired up and ready to go for the second round of substitution. So cosine u du, it's right here, have no fear. Here's my rad sine u, holding up the middle of the integrand, and then 1 minus sine squared u is replacing cosine squared u. Okay? So here we go. Time for this beautiful substitution. Let's rewrite the whole integral now in terms of t. So we have 1/2 1 minus t squared rad t, and then cosine u du is just dt. Woo, good. And then from here to proceed, rewrite square root of t as t to the 1/2 power. So 1 minus t squared times t to the 1/2 dt. We can distribute that through now. So we have 1/2 integral t to the 1/2 minus t squared times t to the 1/2. Add those exponents. That's going to be t to the 5/2 dt. All right, now we can anti-differentiate. So add 1 to the exponent, divide by the new exponent. That's the same as multiplying by the reciprocal. Minus, next one's going to be 2/7 t to the 7/2 plus c. And then I can distribute that 1/2 back through, and the 2's in the numerator cancel out. So lovely. So 1/3 t to the 3/2 minus 1/7 t to the 7/2 plus c. And then we got to go back to our original variable. So remember, we had let t be sine of u. So this is going to be 1/3 sine of u to the 3/2 minus 1/7 sine of u to the 7/2 plus c. And u was not the original variable. Remember, we had let u equal x squared. So we got to take it all the way back to the beginning. So this is 1/3 sine of x squared to the 3/2 minus 1/7 sine of x squared to the 7/2 plus c. That's a lot of parentheses, so if you want, you could write it as 1/3 sine, and then put the little 3/2 here, right? Like we often do when we have sine squared, cosine squared. It's just we don't typically have our trig functions raised to exponents that are not integers, but it still represents the same thing. I just don't know how you feel about it. How do you feel about it? You let me know. Would you rather put extra layers of parentheses, or do you like this last version of the answer? I think it's up for debate. I think the row up above is a little more clear about what's going on, but it can be annoying to write so many parentheses. This one I like, but I'm also not angry about this one. Vote down below which is your favorite, yellow or green. Anyways, I hope you guys were all able to solve that one on your own, or at least came pretty close and enjoyed solving it. And then I am working on making a video going over all 3 Euler substitutions for integration. And then I will revisit integrals that we've already solved using trig sub and other techniques, and then solve them instead using Euler's substitutions, all 3. So that's taking some time to get it put together and ready for you guys, but stay tuned. So make sure you're subscribed and you have your notifications on. And thank you guys so much for your support. You can also catch me on Instagram, TikTok, Twitter, Math with Professor V. Don't forget to click the thumbs up button, give this video a like, and I'll be back sooner than later. Bye guys.